Hi there, welcome to the channel. My name is Mohammed Khajuriwala. In this video, I want to show you how I build an RAG-powered AI assistant using Confluence as the knowledge base. And this can be really helpful where companies and organizations are storing a lot of information on Confluence. A lot of documentation is there and they want to generate summaries on top of that. Or maybe they want to use it to automate their internal processes where they reference their information being stored in Confluence. So let's just jump right into it. So this is how the information looks on my Confluence. I have a couple of pages which talk about the recent AI products and features. Like I have Gemini Nano Banana, Meta Vibes, Anthropic Instructor Tutorial, Google Tunix. So there is a lot of information that I have documented out here. Now, for any company or organization, there can be a lot of pages where they have documented things about their products, their features, their architecture, and it becomes really difficult to fetch all that information. And at times, it becomes difficult for someone to make a sense out of all that information when it is distributed across a lot of pages. So, in order to deal with this, I have designed three N8N workflows. Now, before we go into the details of how it has been uh, designed, let's just see this into action. So this is the Confluence Assistant, and this is the AI agent, which is powered by the OpenAI Gemini 4.1 Mini. It fetches all the vectors that I've stored in Pinecone, which I'll show you later how exactly I do that. So if I throw any question at it, like let's say, tell me about Gemini Nano Banana. So what this will do is this will trigger the agent, which will get all the information from Pinecone, and it will use OpenAI GPT 4.1 to, create a summary out of it and give us the information. And here you can see that, it gives you all the information that it has stored on the Confluence. And at the bottom, it also mentions the page ID. So if you're using this on your website where you're fetching all the information from Confluence, this will give you a page ID at the bottom of the response, which will tell you that, from where it is fetching all that information. Now, let's say if I am getting information from multiple pages, it will display multiple page IDs out here. So if I say, uh, give me details on Google. So I have a few pages which talk about it, like Gemini, Nano Banana, then I have Google Tunix. So if you look at this, it is giving me the information that is there on Confluence, and it also gives me multiple page IDs out here. So this makes your life easy when you want to, go and see where exactly your information is stored. And this will also, give you correlated answers. Like if you wanted to, create a proper answer out of multiple pages. So this will, you can modify this and you can use it into your own work. Now, behind the scenes, what happens is I have two workflows. One is the workflow that fetches all the information from Confluence and dumps it into Pinecone. But the way I do this is I fetch information on a schedule, like on a weekly basis, and I only fetch information that has been changed in the last week or it has been created. So if a new page is created or if an existing page is updated in the last week, it will only fetch those pages and update the vectors in Pinecone which are related to those pages. So I don't fetch everything again every week. I just fetch information that has been changed. Now, in order to do this, I have two data tables. One is the data table which is called Confluence, and it's a simple table. It basically just stores the date on which the process was ran previously. So when I say 12th of October, and if I run it today, what it will do is it will fetch all the pages that has been modified after 12th of October and before 15th, which is today. So it will only fetch the pages that have been created or updated in the last 3 days. Now let's say if I change this to 1st October and I trigger this workflow. I'll just show you how this works and then I can walk you through the entire workflow. So if I run this, it will go and get the date from this data table, and it will trigger Confluence. And here you can see that it is executing a sub workflow, which is Pinecone, which is actually dumping the vectors into Pinecone. And then it will update the date into the data table, saying that the next run should happen from this particular date. So if you see this, if you go back and see the data table, it has changed to 14th, which is a previous date. So basically, if I run this tomorrow, it will change it to 15th. So, and this is how it does on a weekly basis. So if you run every Sunday, it will fetch all the information for a week. Now there are a few other things that which help us do this efficiently. One is that in the start we just fetch the information from this table. We also insert data into a different table which acts like a log for you, which stores information about this execution, whether this execution went successfully or it errored out for some reason. I'll show you that as well. But let's just walk through this workflow before I go there. And here I'm just initializing a few variables like the Confluence base URL, the type of information I want to fetch from Confluence, and this is the date and the space key. And this is the view of how I want to fetch from Confluence. Now, this is an important block where I am triggering Confluence, and the way I'm doing this is I am setting a limit out here. So I'm just fetching 3 pages at a time. Now this can be modified to 25 or 50, which is the max limit, I guess. But let's say if you have 150 pages and you want all those 150 pages, there are a few settings that you can set out here. Like the value out here would be 50. And what you can do is you can set these options out here where it says pagination. So whenever you get a response from Confluence, this is the response. And if you see at the end of this response, it would have something called as a next URL, which you can use. See this is the next URL. So what this does is it gives you a response. It gives you the next URL, which you need to trigger to fetch the information that is not fetched in this particular call. So if you have 150 pages and you're fetching 50 pages at a time, it will allow you to get this next URL and trigger it again. And after the third call, this next URL would be empty. So this you can set it out here in the pagination option. You can say that this is the next URL, and you can set the complete expression. What this does is that when it doesn't find the next URL, it understands that it has fetched all the information, and then it goes to the next node. So this is how you can set pagination, and if you can make sure that you're fetching everything from Confluence in a single operation. Now, out here, you are splitting those results. So since you're making 3 calls, you need to split those results into individual objects. So you can see this, it says 3 items, but within these 3 items, if your my limit is 3 pages. So in the end, this just splits those results. You need to set out here that, within the result, which node is having the actual data. So within body.results, the entire result is. So if I set it out here, it will split the results on the basis of this, and you will get all the pages after this node. So it has 7 pages that has updated before in this duration. So now since I have these 7 pages, I go and call the sub workflow, and out here I'm passing the metadata as well. So if you look at this one, what I'm doing is I'm passing the page ID. Before I show you this, let's see this fields. I'm passing the page ID, passing the title, the data, the actual data within that page, and the space. So in the sub workflow, I use this object and I create vectors for this object, and the other 3 fields, I pass this as metadata. So this is the second workflow. Now, this is also an interesting part where, you just want to update the information. So in order to do that, N8N doesn't have any native node which does an upsert operation. And so what we are doing out here is we are using a LangChain code node, which you can customize, and you can do any operation out here. So this is one code, one node that N8N gives you. If you want to run any LangChain operation, which is not natively available in N8N, you can write the code out here, and it works exactly the way you want it to. It's like a JavaScript code. So out here, what I'm doing is I'm deleting all the vectors which is related to a page ID. So when I store into Pinecone, I set the metadata and I set the page ID for that metadata. So if a particular page has 10 vectors, all those 10 vectors would have this page ID within its metadata. So now this helps in upserting the information. Let's say you had a page which was stored previously and the information is updated on that page. You get this page ID, you delete all those vectors related to this page from Pinecone, and then you set the Pinecone vector store where you are passing that information. Now, when we get the information, we convert it into Markdown, and then we pass that information. So the way it looks into Pinecone, this is the way it looks. It has the page ID, it has a space, the title, and this is the actual data that it is storing. So this is how it is stored on Pinecone. So these are the two workflows which actually fetch the information from Confluence and dump it into Pinecone. And I showed you the third workflow, which actually acts like an assistant. This can further be customized to be used into any workflow, any automation that you have where you want to fetch the information from Confluence and you want to automate the process, whatever your use case is. And this is the other data table where I store all the information recording and execution. So if I execute this week and there is no data that has been updated or inserted, it will say no records. Similarly, if it has errored out, it will say error, or maybe if it is done successfully, it will say done, and it will give me the number of pages that it has updated or created. So this is how you can create a RAG powered AI assistant using Confluence as your knowledge base. If you like the video, then like and subscribe, and I can drop all the code within the GitHub repository and share it in the comments. Thank you.